All right, so we are good to go. Good afternoon, everybody. I call it afternoon even though it's only 11 because it's like later than 10. Um, so yeah, someone posted in chat, time for the rubber ducky method. That's a legitimate method for debugging code is to explain your code to a rubber duck. Um, and it's amazing how often you can find a problem in your logic or your code just by reading it and saying it out loud. It's a trick to help you see, with fresh eyes. And so rubber duck debugging, I mean, you can look it up on Wikipedia. It's a thing. Um, so it doesn't have to. It can be a dog also, or a friend who doesn't mind hearing you talk. All right. So any questions up front? So ODPs, I'm not accepting late, but I am going to switch ODPs to be due at 10 in the morning instead of 8, so that they'll actually be due after office hours, so that if you're really stuck on it, you can come to office hours, get some help, and then hopefully get it assessed and turned in on time. I'm going to change that on Canvas this afternoon. So ODP 407 will be due at 10 o'clock tomorrow morning instead of 8. But this is tentative. If I find that people are completely not doing the ODPs and just coming to office hours to start it, right, then I may go back to 8 o'clock. But for now, I'm going to switch it to 10 o'clock. So you'll see that change in Canvas this afternoon. Um, have you gone over how to loop back if the answer is invalid? So actually, if you hop onto the code area, and there's a link to this on Canvas. We wrote a program in class the other day that that asked the user to type in the word BYE, and if it wasn't BYE, it would ask them again to say bye and get an input from them. And this loop will basically keep looping until they type in, the thing that you're expecting them to type in. And so you can do this to for example, say who should go first, type in a U or a C. And so we could read their answer and we could say if it's not equal to U or C, then we want to ask them again.
And you said for the PA projects, they're kind of open for as long as it works, kind of, because I used a conditional if, elif, and else for that. But
That's fine. Yeah, yeah.
Okay,
As long as you're not going outside of this bash how-to guide, right? So as long as your conditionals look like this or look like that, right? You're okay.
Yeah.
And we also go ahead.
No, it was if that string enter or equal U, then do this. If it equals C, do this. Otherwise, else do something else.
Perfect. That's fantastic.
Okay.
Yeah. So you can use if else's. You can also use ands or ors. And so if you want to say, for example, if this equals U or this equals C, we could do, if bracket bracket answer equals U and then two pipes for an or, this is equal to C, right? So there's multiple ways to do it. And let's think about that logic a little. So let's just imagine that we're trying to find out who should go first, right? The user or the computer. So let's read an answer. Okay, so if answer equals U or answer equals C. This is pseudocode now, it's not bash anymore, right? So this is legal. And I'm going to go ahead and mute everybody, but if you want to chat, go ahead and open your mic. So this is legal. If we wanted to write a condition to say, did the user type in something that's illegal, what would it look like? If answer is not equal to you and answer is not equal to C, that's illegal. And sometimes, we want to write an if statement or a while statement based on some condition. Sometimes we want to do that based on the opposite condition, right? And be really careful with your logic. I've seen lots of cases where somebody, might want to write this, but they actually type an and. Well, if I say if answer equals U and answer equals C, that's never going to be true. Because it can't be U and it can't be C, right? I really want an or. Either they said a U or they said a C. If I want the illegal condition, it's different from U and it's also different from C. If I put an or in here, this is always going to be true. So be really careful when you're working with these conditionals. Step back and take a closer look at them. I don't know how you step back and take a closer look. That's weird. Take a more careful look at them and make sure that this is logically what you actually mean, right? And this is just De Morgan's theorem. Remember De Morgan's theorem from Engineering 250 or CSE 215. If you want to negate a logical statement, you negate each of the individual pieces and you change your or to an and you change your and to an or, right? If this was one statement, the negation of that is, instead of answer equals U, answer is not equal to U. The negation of answer equals C is answer is not equal to C. And the or becomes an and, so this is the opposite of that. So you can use De Morgan to double check your logic sometimes.
Do you have any preference on which one to use, or are they?
It's totally up to you. And
if there's any case where one might be better than the other.
My almost universal rule is the way that makes the most sense to you is the best one.
Okay.
Right? Because my goal for most of this sequence at Clark is for you to come away with as clear an understanding of these concepts as possible. And, other than this funny business of, this is the only way you can write a while loop, for example, in Bash. Other than that, I want you to do the thing that makes the most sense to you, right? Because that's going to be what you're most productive working with. And it'll differ from person to person. All right, so when we're playing the game, part of the algorithm is, how do we know how many sticks the computer is going to take? So if there's a variable named sticks, which is sticks is the number of sticks left, what you really want to take is the number of sticks modulo 4. So you want to take sticks %4. Percent is a modulo operator in C, Java, also in Bash, most languages. So you want to find the remainder when you divide sticks by 4. That's how many sticks you want to take. And so if we make a little table, right? If there's 10 sticks left, how many sticks should the computer take? Take 2. And why is that the right number to take? Because if you leave the other player with a multiple of 4 sticks left, you can win, guaranteed. Right? If the number of sticks left is a multiple of 4, you can always win. Yeah, go ahead.
Can I ask you a question real quick? So, if you pick 15 sticks,
Mm-hmm.
and as the user, you continuously take 3, I found that I would win the game.
Mm-hmm.
Is that an error, or is that just...
If there's if there's 15 sticks and you take 3, the computer's left with 12. That's a multiple of 4. At that point, you can always win.
Okay.
So the computer in that case will take 1, which leaves 11. So if you take 3, now there's 8 left. That's a multiple of 4.
Okay.
So yeah,
That's really that's one way to get out of a computer wins then.
yeah.
Okay, I just want to make sure it wasn't an error in my.
No, that's actually exactly what it should do.
Okay, perfect.
Cool. All right, go ahead and send me an attendance ping. Let me know that you're here. And let's look at this. How many sticks should we take? So this is the computer, right? If there's 11 sticks left, it should take 3, because then the user will be left with 8. That's a multiple of 4. Computer can win. If there's 12 sticks left, ideally the computer would like to take 0, so that the user is left with a multiple of 12. But the computer's not allowed to say, I'm not going to take any sticks. So we just go ahead and we take 1 stick. If there's 13, we want to take 1, so the user's left with 12. If there's 14, we'll take 2, so the user's left with 12. 15, we'll take 3, so the user is left with 12. 16, well, that's already a multiple of 4. We'd like to take either 4 or 0. Neither of those are legal, so we'll take 1. And then 17, we'll take 1, and so on. So this is basically saying take sticks percent 4 unless this is equal to 0, in which case you take 1. So how do we do that? So take equals sticks percent 4. If take equals 0, set take equal to 1. So you have to write that in bash speak, right? You have to put that in the sentences that bash understands. But this is a modulo operator, so you can say $paren sticks percent 4 take equals. Well, that will do this, and take will be either 0, 1, 2, or 3. And then this is an if statement, like from that bash handout. So if bracket bracket $take dash eq 0 bracket bracket, etc., etc. I'm going to write an attendance taking reminder for myself. I think we're going to pop up an attendance ping randomly, because I tend to forget. So that'll be my project for the afternoon. All right, let's see. Had a number of people come to office hours this morning, and we worked through homework 2, and got several people to where they were able to submit their homework 2, and I was able to download their repository. If you have not yet finished homework 2 and gotten a 20 out of 20 on it, you got to come to office hours. We got to nail this down, right, before Friday, so that you can upload programming assignment 1 and get credit for the work you're doing on your stick program.
So I did want to ask on that. Once you push it and it gets into your repository, that's it, right? That's submitting it.
Yeah. So once you git add, git commit, git push without errors, I should be able to download it.
Okay.
If you're not positive that you've done it correctly, you can send me a note today or tomorrow and say, hey, can you double check, right? But I'm not going to do that Thursday, because I'll
I can see it in my repo. I can see it backside in the GitLab.
Okay.
And it is there. I just wanted to make sure that was submitted. I didn't have to do another step.
Nope, that should be it. So here's kind of the bigger picture Git setup. You should have somewhere on your system a CSE224 directory. And underneath that, you should have a homework 002 subdirectory. And underneath that, you've probably got a README. And that's probably it. All right, underneath CSE224, you're going to want a directory called PA1. And in that directory, you're going to have your program called stick. And you might have a README in there if you want, or some other files or whatever, but at the minimum, you want this file called stick. And then when we get to PA2, you're going to create a PA2 directory, and underneath that, you're going to have, I think it's going to be called a stick.c, and there might be some other stuff in there, and so on. Okay? But you want this kind of directory structure. You want one main directory for the course, CSE224, and then each of your homeworks is a subdirectory underneath that. And assuming you've got it set up like this, get a init, you only had to do once. You did that for homework 2, you don't do that again. Don't do a get init in here or here or here, it will confuse Git. Right? This is all one repository. So you do get init once when you created CSE224, you're done. No more get inits. Similarly, git remote add origin. You did that once when you created CSE224, you're done. Don't have to do that ever again. Right? So these are all just directories underneath this main directory that's already a Git repo. So if I make a directory PA1 and I make a file called stick, and then I want to add that, right? From this directory, all I have to do is git add. I could do stick or I could do star, git commit, and then git push origin master. And I'm just going to do those every time that I make changes, every time that I have a new file, git add star, git commit, git push origin master. And you might have an ODP directory. And under your ODPs, you might have ODP 401, you might have an ODP 402, and you might have files underneath and so on and so forth. That's totally fine too. All right? I won't look at those in Git, but that's totally fine.
Is it considered safe to just go to like your CSE224 directory and then do all of your Git commit and push just from your main directory, so you're just pushing everything every time?
I think that if you make changes to stick and you go up here and say git add star, I don't know if it'll pick up stick. I think it will. Try it and see. But certainly if I'm in my PA1 directory and I'm working on this file stick, from that directory, if I say git add star, it will do that. But yeah, I think if you go up to your top level directory and do git add star, it'll do the whole tree. But as your directory grows, it takes longer and longer to do that, so depending on your tolerance for waiting. And yeah, you can have your ODPs here, and then they're under Git control, and if you want to go back and refer to them, you know, later in life, right, they're in the same repository as all your other CSE224 work. That can be kind of nice. And your repository can be, I think, 10 gigabytes. That's the allocation you're given per repository from GitLab, so we won't come close to touching that, right? We'll be lucky if we get up to a megabyte of code, so that should work. All right, if you've already done something different from this, if you created a PA directory and underneath that put PA1, you're going to want to change things around to make it look like this. Okay, this is going to be really important that it looks like this so that I can find your assignments when I go to grade them. So if you need to move things around at this point, probably the easiest way to move things is rename this directory. Right, so do something like move, go into your top level directory, move CSE224 to CSE224 old or something like that. Just move it out of the way. Don't delete it if you've already got code written, right? But just rename it to something else. And then go to gitlab.com, get rid of your CSE224 repository, right? And now make a CSE224, do a git init, git remote add origin, and just build this structure exactly the way that we want it to be, and copy your files from this old area into here. So you can say copy old new, it'll make a copy of your file. leave this unchanged because you've got code in there, you've got ODPs, maybe you've started your stick program, right? But just rebuild that whole directory structure. That's the easiest way to do it. We can move things around in here, but it's more complex. And if things go wrong, it can get very mysterious looking.
So you don't want branching files, you just want one layer?
What do you mean by branching files?
Or like branching directories. You just want it all under CSE224.
So I want PA1 directly under CSE224. I want PA2 directly under there, and so on. Yeah.
Okay.
All right. So let's talk about ODP 406. So this was printing out a set of pipes with a number in parentheses afterwards. And here's an example of how to do that, right? So in this case, I was reading a number from the user, initialized a loop counter to 0, and then as long as my number was less than the number that I wanted, I take another pass through this loop where I print out a pipe with no new line at the end, and then I increment my counter. So if num is 5, this loop will execute a total of 5 iterations, and each iteration it will print out another pipe. So at the end of this, when I'm done with my loop, I'll have printed, num pipes side by side, and then I just go ahead and print out that number in parentheses. So that would work for ODP 406. And you can use, a version of this logic in your stick program when you're trying to print the pile of sticks. So ODP 407 is a little different. The logic that you're going to use in this ODP is the same logic you can use in your stick program, but this is doing something fairly different from what your stick program is going to do. So let's just take a look at how this works. Well, let me talk you through the assignment here, right? So you're going to print out a prompt. You're going to print a number sign, and that's it. No space, no new line. Just print a number sign and wait for the user to type in a number. Okay, so print a number sign, no new line. Read a number from the user. And now test that number to see if it's between 1 and 3. If it's bigger than or equal to 1 and less than 3, print out OK, 2 characters followed by a new line, and exit. You're done. But if the number they type in is not legal, if it's not between 1 and 3, print out ERR, 3 characters followed by a new line, and then prompt again. Print a number sign, no new line. Read another number from the user. So same thing you did up here. This is your second attempt at reading a number from the user. If the number is legal between 1 and 3, print OK, 2 characters, no new plus a new line at the end, and exit. Otherwise, print the word fail, followed by a new line, and exit. Okay, so this is the part of your stick game where you say, how many sticks do you want to take? And hopefully they type 1, 2, or 3. And if they type, 75 gazillion, you print a message saying that's not a legal number. How many sticks do you want to take? And if they still put in a bad answer, then you say, okay, the game's over. And an important note, just for the ODP, right? If you want to read input after typing a prompt, you can do it by using this -p switch on the read command. Don't use that for the ODP, right? You won't get 10 out of 10 if you use a read -p. If you want to print a number sign and then read a number from the user, print the number sign using echo-n, quote number sign, and then just use a read statement, read number, to read the number from the user. Right? Read -p does not do exactly the same thing as an echo-n. It does something slightly different, and it'll trip up the assessor. So what should this look like? If you run this script that you're going to assess, it prints a number sign and it just sits there. There's no space, there's no new line. It printed 1 character and it's waiting for me to type a number. And if I type a number between 1 and 3, it says, okay, new line, and we're done. If I run it again and I type an illegal number, it says error, ERR, and then it prints the prompt again and waits for me to type a number. And if I type something legal, it says OK. The third use case is, it prints the number, I type something illegal, it says error, asks me again, I type something illegal a second time, now it says fail. So in order to do this ODP, you need to be able to do the logic you're going to do in stick. But this is not, a part of your stick program. Your stick program never says things like fail or ERR or OK, right? And it doesn't just print a number sign and sit there, right? But the logic underlying this, the code you have to write to make this happen, is similar to the code that you'll write in your stick program. All right, so that's ODP 407. And like I said, I'm going to switch the ODPs to be due at 10. So try and get this working on your own, and then if it does not work, you can come to office hours in the morning and we can look at it. But let's look at the logic for ODP 407, as well as the logic for how we find out how many sticks the user wants to take. So ask how many sticks. And let's read the answer from the user. I'll call it num. You can put it in whatever variable name you like. So I've got my number of sticks. Okay, so if it's legal, we're just going to go ahead and continue the game. We're going to take that number of sticks off the pile and so on and so forth. What's interesting is if it's not legal, then we got to do some stuff. So, say not legal. Read the number of sticks again from the user. And if the number they put in here is legal, we'll just continue the game. So again, the interesting thing is, if it's not legal, say goodbye and just exit the program. All right, so if I use curly brackets like we do in C to group this stuff, right, here's what the logic looks like. We're going to ask the user how many sticks, we're going to get a number from them, and then we're going to do a little test here to see if it's legal. And if the number wasn't legal, we'll try once more to get a number, and if it's not legal, we'll exit, right? If we make it through this block of code and we get down here, we know that num is the number of sticks they want to take, and it's a legal number. Maybe they put that legal number in the first time, maybe it took them 2 tries. We don't really care. We're continuing the game, and I'll just put a number down here, right? User will take num sticks. And I'll continue, I'll take that off the pile, see if the game's over, and so on and so forth. So this is pseudocode, right? It's not bash, it's not C, it's something higher level. But we can turn this into bash, right? But we got to do a bit of work. So first of all, what do we mean by not legal? Well, not legal means the number is not between 1 and 3. So we've got to do some logic, right? So something like, if number is bigger than or equal to 1 and number is less than or equal to 3, that's legal. Right? It's got to be a number bigger than or equal to 1, less than or equal to 3. If we want to know if the number was not legal, well, use De Morgan's theorem. Negate this condition. Well, if the number is not bigger than or equal to 1, it must be less than 1. Negate this condition. If the number is not less than or equal to 3, it must be bigger than 3. and change your and to an or. So if the number is smaller than 1 or bigger than 3, it's not legal. And then we can write that in bash by, using these for less than, greater than, and putting things inside double brackets and using the keyword if, and using, if we want an or operator, using a double pipe. So using pipe for or double ampersand for and, right? So if first condition or second condition, and so on. So that's one way to do this. And this is where it's helpful to sort of break your code into smaller pieces, right? You could just write a script like, hey, ODP 407, for example, right? That just does this logic, gets a number and checks to see if it's legal. Well, that's exactly what ODP 407 is, right? If it prints okay, it means we're down here, we're going to continue playing the game. If it prints error, it means we're in here. If it prints fail, it means we reach this point. So a lot of times these ODPs are really, exercises in developing pieces of a larger project, right? But you don't need to wait for me to post an ODP. You can come up with this on your own. But the ODPs I'm posting and assigning in this course are meant to, give you an idea on how you might develop pieces of your programs on your own. And as you move to a point where you can come up with these by yourself, right? That's a big step in becoming a faster and more confident and stronger programmer. So this is all not just busy work, right? There's a method to the madness.
So for PA1, we're developing these ODPs, and I tried it last night. I found that I modified the ODP to work for my code. I could just call that one piece. Is that how you want us to do it?
So my expectation is that, after you've written the logic for ODP 407, you might like copy and paste that into part of your code. Or like ODP 406, you wrote, a while loop for printing out a bunch of pipes, right? You might copy and paste that into 2 or 3 places in your stick program. You can put that into a function and call it as a function, but we haven't talked about functions yet. And I'm resisting talking about functions for another few weeks because they can help you in some cases, but they can really confuse you in a lot more cases. And so I'm just trying to keep things really straightforward right now. But if you're talking about putting that in a function, that's totally cool.
I assume it's a function. I mean, I just left it as the file, and I changed it so it was command line, so that when I call
Okay.
my main script, like it says call, I called it stick print, call stick print, and I gave it the argument
Okay.
of how many sticks I had, and then it said, oh hey, look, I'm gonna print this out for you.
Cool. Okay.
That way I was thinking I wouldn't have to like print it, copy that section of code over and over in my main code.
Okay.
If I want it in the main code, I'm cool with that.
So stick print is a separate file?
Yes.
That's totally fine. Just make sure you include it in the Git repo.
Okay.
So as long as that's added and I downloaded, yeah, that should work great. That's a good way to do a function, actually. All right, let's see. Where are we? Other questions? All right, so let's talk more about some of the logic of the stick program. And I started making some comments at the end of class yesterday about changing the assignment, right, for yourself as you're developing it. Make the problem easier, right? And so some things I suggested, for example, you could say, I'm always going to play with 25 sticks, and I'm always going to let the computer go first, and I'm not going to worry about illegal moves, and I'm not going to worry about printing a bunch of pipes to see what the stick pile looks like, and I'm not going to worry about when the game is over and who won. Okay, well, we've got something we don't want to turn in for the final project, but we've got something that if we get working, we've got a really good start on our programming assignment 1. But with a much simpler set of requirements. So start with, number of sticks equals 25, and have the computer go first. So calculate 25 mod 4, and you're going to end up with 1. So print a message, computer's taking 1 stick, subtract 1 from that 25, now you've got 24 sticks. Now ask the user how many sticks they want to take, and forget about all of this stuff. Just get a number from them. Subtract that from the pile of sticks. The user said they want to take 2. Okay, now print out there's 22 sticks left. And put those 2 chunks of code in a while loop, and hey, you've got something that does a pretty good first version of playing this game. Computer makes a move, you make a move, computer makes a move, you make a move. Right? It's not the finished product, but it is so much easier to have something that does something kind of like what you want and then start adding some polish to it. That's a whole lot easier than staring at an empty screen for an hour thinking, how do I start? How do I start? Right? So avoid the writer's block, avoid the empty page syndrome, get something running, right? And it's pretty fun, to be able to, have the computer make a move, you make a move, and so on. If you don't want to deal with this modulo business, just have the computer always take 2 sticks. It's a simplification, but it lets you set up, the interaction of, getting a number of sticks the user wants to take from the user, alternating who's taking piles who's taking sticks off the pile, and it lets you put the whole thing in a loop, right? That's a pretty good framework to start building to. And then, start adding the details. So instead of always taking 2 sticks for the computer, do your business of, take the number of sticks left modulo 4 and take that many sticks. But if it's equal to 0, I'm going to take 1. Right? Now you got some arithmetic, you got some logic in there, you got some conditionals and so on, right? Once that's working, throw in some logic to see when the game ends. Because if you don't do that, you'll just keep taking sticks, you'll go to negative piles, right? But keep adding details to it. That's a reasonable approach to working on larger projects. Start with something simple and then build it up. Comments in Bash. So in Bash, you do a comment by typing a number sign. I don't think there's a built-in block comment. You have to put a comment in the beginning of every one. Maybe there is, but bunch of number signs on each row doesn't look bad. They kind of line up nicely. So we usually just do that.
I found that it just keeps that line, and it just it doesn't the line. It seems like you have an infinite line so far. As far as the comments go, I put in pound and then I type a big long string that starts to fill multiple lines because of my.
Yeah, that's all technically one line, but if your editor is wrapping for you, it'll look like it comes out on multiple lines. But that can be a little tricky because not all editors will do that. Some editors will shrink the font so that your entire line fits in your window and then the whole thing turns tiny. Some mail programs do that too. It's not uncommon to just put a bunch of number signs, bunch of comments in the beginning, and have a number sign in the beginning of each one. Whatever looks good to you is probably the appropriate way to do it.
Is there a fairly safe line character width that most editors typically stay within, or before wrapping or adding a gridded line?
We're going into some history here, but you are always safe and arguably in a cool kids club if you do 80 characters per line. Okay, why 80? So VT100s, which are the most commonly emulated terminal out there, PuTTY, you know, by default emulates a VT100. Well, VT100s were 80 characters wide. And why were they 80 characters wide? Because Fortran, we just passed an anniversary of Fortran, I think the 50th. Fortran, by default, went 72 characters on a line. And you type these on Hollerith cards, and Hollerith cards had 80 characters going across. So 80 is pretty safe. 120 or 132 are less common defaults. But, you know, pretty much any window that you work with, 80 characters is going to fit. And, you know, my console window by default, it's 80 by 25 or 80 by 24. So that's a good size. Nobody's ever asked that question in this class. That's awesome. So comments in general, right? For the stick program, I want you to put a comment block in the beginning. I want you to comment your code. In general, right, you're writing comments to describe what's going on in your code for your benefit, to help you keep track of things while you're developing the code, but then also for the benefit of somebody who might be reading your code, that's me, to you know, use it or grade it or whatever. And knowing what to comment and how much to comment is something that you know, that's part of what you're learning in taking these courses. So if you took Engineering 270 with me, we talked about commenting in there. But you know, trying to find a sweet spot for how much should you comment and what should you write, that's something that takes practice, basically. And almost never have I had a student do too much commenting, right? Now that's not a challenge, but you know, almost always if there's an error, it's on the side of not enough commenting. Now Bash is pretty high level. You could write something like this, right? And maybe, you know, put one comment in the beginning saying, like, you know, make sure user's entry is legal. And if not, you could put a message here saying, like, give them one more try. And then around here, I would say, you know, 2 illegal entries in a row means the game is over. That's just, you know, stuff that is helping me go back and look at this later and understand from a high level what's going on with this logic, right? Instead of having to kind of reverse engineer the code. So that's the kind of commenting you want to put in. And the other thing that goes along with this is indenting. And, you know, indenting in Bash and most other languages makes no difference to the compiler. Python's an exception. But most languages, how you indent is really just kind of up to your own personal style. But I want you to do some kind of indenting, right? When you're inside a loop, indent some part of that. Now, do you indent the word while? Do you start indenting with do? Do you indent done? That's up to you. There's tons of religious wars online about the proper way to indent code. I don't care, but I want you to have some kind of style. If all of this was sitting inside a big if statement, I would like to see it all moved over, indented some amount, right? And indenting is a way that when you're looking at your code, you can quickly tell what level of logic you're looking at. This read statement, I know this is at the top level because it's flush on the left. This read statement I know is inside something. It's in a loop, it's in an if statement, it's something, right? And I know that this is at the same indent level as that, so if this statement executes, right, this statement's also going to execute. And, you know, some people indent by a tab, 8 characters. Some people indent by 4. I start indenting by 2. But that's also personal taste. But again, you know, develop a style or you know, find a style if you haven't developed one and be consistent in it, right? And it will definitely help you. And this other C book that I posted on Canvas, I can see clearly now, that's got, you know, a short chapter on indenting and commenting that sort of expands on some of these ideas.
I have noticed that spacing matters with like where you put your equals and
Spacing matters in Bash, and Bash is kind of unusual that way, right? This has to be a space, this has to be a space. You can't have a space in between here and so on. In C and in Java, right, spacing is pretty much up to us, right? Other than, if you have, if X, you can't have, keywords next to each other without a space and things like that. But Bash is very particular about it. So Bash, you got to follow the rules described in this handout for it to be legal syntax. But spaces in the beginning, totally fine. Right, so I can do a bunch of spaces, x equals 12, I can echo x, and I get a 12. But if I say x space equals space 12, I get error messages.
yeah, I was running into that last night, and I think if I was figuring out that it doesn't like that space.
Yeah.
Put in there.
Yeah, it's a funny language that way. I've seen bash lines with just a single bracket. Do you mean a single space, or do you mean literally a single pair of brackets? I'm not sure what that actually refers to. Oh, you mean like the while statement. So I think you're saying you've seen while loops with just a single bracket instead of two. Yeah. So you're required to use double brackets in this course for while statements and for if statements, right? You will lose points if you only use one. Is one better than the other? I think the double brackets get you more things. The syntax of Bash has evolved over the years. And it still understands single brackets. It also understands parentheses in some cases. Sometimes one parenthesis, sometimes two parentheses, right? So yeah, just stick with the doubles and you should be safe in this course. But if you want to pop some popcorn and hop on Stack Overflow and see what the differences are and maybe post some questions, that's always good fun. Yeah, there is a functional difference. And I think doubles are an extension of singles. I think singles are a throwback to the corn shell, but I'm not up on my bash history. All right, we got 2 minutes left. What should we do in 2 minutes? I will talk more. Send me an attendance ping. We're at the end of time here, so send me an attendance note. Let me know you're here. I will talk more about the stick program tomorrow, about sort of a higher level view of how we can organize the logic flow. But like I say, starting with a simpler version and then adding some details will get you pretty far. The business of who goes first and setting it up so that either the user or computer can go first, that can be a little bit tricky, but I'll show you 2 different ways to do that. One with a state variable and one with a special case. But other than that, I think tomorrow we'll start digging into some other aspects of Linux and Bash scripts, and this will eventually lead us to being able to write functions. But we'll play around with this for the rest of the week, and then next week I'm going to shift gears and start talking more about C. And your second programming assignment will be a C program. It'll be a C version of the stick game with a few changes. So we got lots of good stuff coming up. All right. I will see you either in office hours tomorrow morning, or I will see you tomorrow. Have a great afternoon. Thank you.
Thanks.